Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss our week 4 our 1 tutorial for both NFTF and FTF questions for subtopic 2.3 Hess'S law. The learning objective for non-face-to-face questions is for you to apply Hess'S law to calculate enthalpy changes using the algebraic method and also energy cycle method. So basically, these two methods will give you exactly the same answer. So the first question asks you to state the Hess'S law. Hess'S law states that when reactants are converted to products, the change in enthalpy means the heat absorbed or released is the same whether the reaction takes place in one step or in a series of steps. So whenever you go, you are going to get exactly the same value. Okay? For questions B, they ask you to consider the following reactions. So given to you these two thermochemical equations of A to form B with delta H1 of positive 30 kilojoule and for B to form C, delta H2 of positive 60 kilojoules. So we call this as given equations. Okay, given equations is to aid you to find the final reactions. And then for B1, by using algebraic methods, they already state to use algebraic method. You cannot choose to do energy cycle method if they already asked. Then calculate the enthalpy change for the reactions. So the enthalpy that we are interested in is this one, from A to become C. Whenever we are asked to use algebraic method, we need to rearrange the thermochemical equations given up here to suit the targeted equations here. So we call this as targeted equations. So if you see on your targeted equations, we have A on the left hand side and C on the right hand side. So by all means, you need to suit the given equations with the targeted equations. So we already have A on the left hand side and C on the right hand side. So whenever you have the same species located on different sides, then we can simply cancel them out. How are we going to cancel them out? By adding these two values. So we know that our delta H reaction is going to equal to delta H1 plus delta H2. Simply substitute the value, then you will get positive 90 kilojoule for the enthalpy of reactions A to become C. Question B2 asks you to construct an energy cycle diagram for substances A, B, and C and show how Hess'S law applies. So this is another method to calculate the enthalpy of reactions. We're going to use exactly the same thermochemical equations as given in previous slide, but then we are going to apply energy cycle method. Okay, usually we'll start with the targeted equations. So our targeted equations is A to form C with delta H reactions. Please write your delta H reactions on top of your arrow. And then in order for A to form C, there's another route that we can take via B. So we're going to have A to form B with delta H1 of positive 30 kilojoule and then B to form C with delta H2 of positive 60 kilojoule. So how are we going to calculate the enthalpy of reactions? We're going to apply the anti-clockwise and clockwise manners. So clockwise is the one that turn clockwise. So like this, according to the clock. And then for this one, from A to C via H1 and H2, we're going to use anti-clockwise manners. So we're going to equate this clockwise and anti-clockwise as enthalpy of reactions equal to delta H1 and delta H2. Substitute the value and you will get exactly the same value as in previous method. Moving on to face-to-face questions with the same learning objective as in non-face-to-face questions. Hydrazine, N2H4, is used as a rocket fuel since its reactions with oxygen is extremely exothermic. So given to you the thermochemical equations of N2H4 in liquid states, react with oxygen gas to form nitrogen gas and 2H2O in gaseous states. with delta H of negative 534 kilojoule. So it is easier for you to put number for each of these delta so that you won't be mistaken with any other enthalpy. Next, calculate the enthalpy of reactions when liquid water is produced instead of steam. So, from the given equations, we have in gaseous state water. Now, our targeted equations, we want to get these 2H2O in liquid states. So, up here is our given equations. Down here is our targeted equations. Okay, and if you can see down here, we are given another thermochemical equations of H2O in liquid state to form H2O in gaseous state. So we have another enthalpy given here. So this one belongs to the given equations. So now the questions didn't state any method to be used. So you are free to choose whether you want to use algebraic or energy cycle method. So my advice to you, if you're given a limited number of enthalpy like this, you can just proceed with algebraic method. It is much easier. Okay, so now we're going to do it one by one. So you're given two equations and also you have one targeted equations. For any chosen method, you need to start with a targeted equation. So we have our targeted equations, then we need to define this as enthalpy 3 or any numbers that follow the orders, and then followed by given equations. So in algebraic method, we need to rearrange the given equations by all means to suit the targeted equations. On your targeted equations, we have N2H4 and also O2 on the left hand side. So check if we have one in given equations. Yep, so we don't need to modify this. Then on the right hand side, we have N2 gas and also 2H2O liquid. So we have the N2, but we got no 2H2O in liquid states. Okay, so we need to do something with this 2H2O gas. So look at another given equations. We have the H2O in liquid states, but at the moment they are on the left hand side. In order to suit the needs of targeted equations that wants the 2H2O liquid on the right hand side, means we need to reverse these equations to the right, and then since we want 2 mole of H2O, then we need to times it with 2. So we need to modify this delta H2 a bit by reversing and also times it with 2. Then we're going to get a new modified equations of 2H2O gas to form 2H2O liquid. Okay, so now we already have our 2H2O liquid on the left hand side, means the one that have the same species but on different side, we can cancel them out. So we're going to cancel out these 2H2O and also 2H2O. Then we can calculate the enthalpy of H3. But before we proceed to the next step, we need to first calculate the enthalpy 2, which is negative 81.4 kilojoule. Lastly, to get delta H3, we need to sum delta H1 and also modify delta H2 like this. Then substitute the value, then you're gonna get negative 615.4 kilojoule. For questions 2, we were given two thermochemical equations of sulfur react with oxygen gas to give sulfur dioxide with delta H negative 297 kilojoule. So we first define this as delta H1. Next, we're given sulfur dioxide react with half mole of oxygen gas to give sulfur trioxide with another delta H. So now we're going to define it as delta H2. So we want to calculate the delta H for the following reactions using energy cycle method. Since these questions already tells you to use energy cycle method, means if you choose to do the algebraic method, you won't be given marks. So we have sulfur react with 3/2 oxygen gas to give you sulfur trioxide. So the one that we don't have any value for its enthalpy is our targeted equations. Okay, so for whichever method that we're going to use, we need to start with targeted equations. So for this energy cycle method, always starts with targeted equations like this, and remember to write the delta H on the arrow. Okay, now, so we have delta H3 of sulfur react with 3/2 oxygen gas to give you SO3 gas, followed by the first delta H, which is sulfur react with oxygen gas to give you SO2 gas. So we have another delta H of delta H2. So we know that delta H2 propose the thermochemical equations of SO2 react with half O2 gas to give you SO3. So don't forget to write the delta H on the arrow together with the units. Never write this O2 on the arrow. So lastly, how are we going to calculate this enthalpy? By applying clockwise and anti-clockwise manners. So again, clockwise manners, the one that turn this way. So we got only delta H3. And then for anti-clockwise is from delta H1 to delta H2. So we're gonna equate these two, delta H3 equal to delta H1 plus delta H2. So we're gonna get value of negative 396.0 kilojoule. That's all for week 4 our 1 tutorial. Thank you.